Hello, my name is Alex Theg, and I'm a founding software engineer in the Space and Sensors division at Tomorrow.io. It's a privilege to speak to you all here at GitCon about launching software into space and how we're transforming global weather forecasting. At Tomorrow.io, we're on a mission that's as bold as it is impactful to empower actionable weather insights from space. By building and deploying space-based data systems, we're helping countries, businesses, and individuals manage all kinds of weather-related challenges with unprecedented accuracy and immediacy. Today, I'd like to take you deeper into the software that helps make this mission possible by focusing on two of our key satellite programs, Pathfinder and Sounders. Together, these satellites enable us to capture and deliver high-quality data that supports Tomorrow.io's mission to empower actionable weather insights. Pathfinder is our active Ka-band radar satellite designed to collect data on atmospheric and environmental conditions. My work on Pathfinder has centered around developing and refining the code that controls and optimizes this data collection process. This includes everything from managing the timing of radar pulses to adjusting parameters in real time, ensuring we gather high-quality data with maximum efficiency. Sounders, meanwhile, is our passive microwave radar focused on capturing natural radiation to image important environmental data on Earth. Here, I've been part of the team responsible for downlinking data, writing code that ensures information is packaged and prioritized for our incredible science team to process. This software was carefully optimized to handle the limited bandwidth and communication windows available in space operations. The first part of our session today will focus on the software that enables precise control over Pathfinder's data collection in space. Let's take a closer look at how we manage data control and collection for Pathfinder and the unique challenges of operating a software-defined radar remotely. Pathfinder is equipped with Arena, our proprietary cutting-edge software-defined radar. Arena itself is responsible for the autonomous collection of data, adapting in real time to gather crucial atmospheric and environmental information from space. This advanced hardware operates independently, making it a powerful tool that sets us apart as leaders in the industry. Our software plays a vital role in configuring and controlling the Arena. We write code that allows us to adjust radar parameters on the fly, setting the Arena up for each mission by fine-tuning its pulse timing, setting collection parameters, and adapting configurations based on the mission's needs. In addition to collecting radar data, the system also gathers telemetry data, which provides crucial information on the health and performance of both the radar system and the satellite overall. This combination of Arena's autonomous capabilities and our software's precise configurations allows Pathfinder to deliver consistently high-quality radar data along with vital telemetry information, meeting tomorrow's mission for actionable weather insights across the globe. With this strong foundation in data collection, the next step is ensuring that the data is effectively transmitted back to Earth. While Pathfinder and Sounders both collect and downlink data, in this next section, I'll be highlighting how we handle downlinking for Sounders. After Sounders collects radar and environmental data in space, it's transmitted down to Earth through a network of ground stations. These stations capture the data during scheduled communication windows, allowing us to efficiently transfer large volumes of radar and environmental information within those limited time frames. In addition to the radar data, the downlink also includes telemetry information. This telemetry data is essential for monitoring the data and operational status of the satellite, as well as ensuring the quality of the radar data itself. Together, the radar and telemetry data form a complete picture that helps us verify and maximize the reliability of the information that we're collecting. Once the data reaches the ground, it enters a processing chain designed and created by myself and other talented engineers here at Tomorrow.io. This chain is structured to handle the data effectively, preparing and distributing it for analysis. From there, the data is processed into standardized weather products by our data science team. Our software's role in this downlinking and processing stage is to manage formatting, organizing, and encryption of data from satellite to scientist. This ensures that every piece of information, from radar measurements to telemetry data, reaches the ground in a ready-to-use format, perfectly aligned for the next steps of the processing chain. Ultimately, this entire system, from downlinking to processing, enables us to deliver data that supports Tomorrow.io's mission of actionable weather intelligence worldwide. Developing software for space applications brings a unique set of challenges, and it's in overcoming these challenges that we've seen some of our greatest successes. One of the biggest challenges we faced was expanding functionality within a legacy codebase, Arena's software, which is about 15 years old and hundreds of thousands of lines deep. Anyone who's inherited a legacy codebase will agree, efforts at extending or refactoring will be difficult. With our lean team of engineers, we were able to both improve and extend this existing codebase to meet the specific requirements of the Pathfinder project, rather than assume the risk and overhead of building something new from the ground up. To make things even more complex, the Arena codebase wasn't even initially managed in Git. It was originally managed through a repository version control tool called Subversion. I vividly remember this migration where I performed a three-way merge between a cutoff revision in Subversion, a first cut of Git, and another branch under active development. This meant manually combing through hundreds of thousands of lines by hand to reconcile changes, all in an active development environment. Maintaining Git commit versioning was paramount during this process, and GitKraken's visualization of the commit history was absolutely crucial. It gave me the clarity I needed to carefully track changes and complete the migration successfully. Another challenge was maintaining compatibility between new developments for space applications and existing Arena deployments for customers. As we developed specialized features for Pathfinder, it was essential that these changes did not disrupt the product's stability or functionality for existing clients. GitKraken once again played an important role here, allowing us to visualize and manage the branch structure so we could maintain a stable version for existing customers while branching out for space-specific modifications. This clear structure helped us compartmentalize changes, ensuring that both branches of the code met their respective needs. Successfully navigating these challenges allowed us to create a version of Arena that could support our goals in space without sacrificing the integrity of the product for existing customers, marking a significant accomplishment in terms of flexibility and adaptability. In a project as complex and distributed as this, efficient collaboration and version control are essential. This is where Git and GitKraken come into play. With a team spread across various locations and disciplines, ranging from engineers to scientists, Git has been fundamental in managing our codebase. GitKraken in particular has provided a powerful interface that allows us to visualize and manage our branches, making collaboration smoother and more efficient. Using GitKraken, we're able to track changes, handle merge conflicts, and maintain a clear history of every update to the code. This has been invaluable when working on high-stakes features, as it ensures that all team members are aligned and that each update integrates seamlessly with the larger system. In essence, GitKraken allows us to build and refine our software with confidence, even when we're dealing with complex concurrent development. This toolset has been crucial in our success, allowing us to synchronize contributions from various teams and maintain the rigorous standards required for space-based software. At Tomorrow I/O, the work we do with software development goes far beyond just writing lines of code. The true purpose of our software is to create a lasting impact by transforming complex data into actionable insights that serve a diverse audience. To illustrate, let's look at some of the data our software helps process. Here's an example of radar precipitation data from our Pathfinder satellites. This plot is one of the first of many near real-time scans of precipitation and atmospheric profiles of weather patterns, enhancing forecasting accuracy for any point on Earth. Our code is designed to handle vast amounts of data like this efficiently, ensuring it reaches end users in a format that's easy to interpret and act on through our software as a service and data as a service platforms. Next, we have a data set from our Sounder satellites, which captured critical information during Hurricane Helene this past September. Our data pipeline ensures that this data flows smoothly from space to our processing chain, where it's transformed into insights that aid regions in responding to severe storms. But ultimately, coding is just the tool. The goal is to make a real-world difference for our customers, which includes everyone from Fortune 500 companies to local businesses and governments. And through our nonprofit initiative, Tomorrow Now, we're also able to help communities in need, such as farmers in Africa. By providing precise weather insights, we empower these farmers to plant and harvest their crops at optimal times, helping to prevent catastrophic losses due to the lack of access to weather forecasts. In the end, Our work in software development is about more than just technology. It's about creating a resilient world where people can make informed decisions based on reliable, timely weather data. This impact-driven approach is what makes our work truly meaningful. To wrap up, I hope this presentation has given you a deeper look into the work we're doing at Tomorrow.io and the role software plays in our mission. Thank you.